July 28, 1944. The hedgerow country, south of Saint-Lô, France. Sergeant James Rothwell's Sherman lurched forward through the narrow sunken lane, its 75mm gun traversing left as the tank advanced. Through his periscope, Rothwell watched his gunner, Corporal Eddie Hansen, tracking a German position 200 yards ahead, while the Sherman continued rolling forward at 8 miles per hour. Hansen squeezed the trigger. The gun fired. The Sherman never stopped moving. The shell struck within meters of the German machine gun nest. Before the enemy crew could recover, Hansen had already loaded another round, compensated for the tank's continued motion, and fired again. This time the position went silent. This tactical innovation, unremarkable to American crews who had been practicing it for months, violated every principle German tank doctrine held sacred about gunnery and fire control. German tankers had been trained since 1939 that accurate fire required a complete halt, careful aim, and deliberate shot placement. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The concept of firing effectively while moving at tactical speeds seemed impossible to crews who had learned their craft in machines designed around fundamentally different combat philosophies. What German forces encountered in Normandy during summer 1944 was not merely a different approach to armoured warfare, but a comprehensive tactical system built around mechanical capabilities German engineers had never prioritized. The Sherman tank's ability to deliver reasonably accurate fire while advancing would force German armour crews to completely reassess their understanding of mobile warfare and expose critical weaknesses in their own vehicle designs that no amount of superior armour or firepower could overcome. The story of marching fire begins not on European battlefields, but on American proving grounds, where ordnance officers and tank crews spent years developing a capability that would fundamentally alter the dynamics of close-range armoured combat. The concept emerged from painful lessons learned during American tank development in the 1930s, when the United States Army possessed virtually no modern armoured forces and had to build institutional knowledge from the ground up. In 1940, the United States Army possessed approximately 400 tanks total, most obsolete M2 light tanks with riveted armour and 37mm guns. American tank doctrine in 1940 emphasized infantry support rather than independent armoured operations, reflecting both equipment limitations and tactical thinking, heavily influenced by World War I experience. Tank gunnery training focused on stationary firing from hull-down positions, with accuracy standards measured exclusively during static exercises. The fall of France in June 1940 shocked American military planners into recognizing that modern armoured warfare demanded capabilities far beyond what existing doctrine contemplated. German blitzkrieg tactics demonstrated that tanks operating as independent combined arms formations could achieve decisive operational results. This realization triggered urgent efforts to develop not just new tanks, but entirely new tactical approaches to armoured combat. The M4 Sherman emerged from this period of intensive development. Production began in February 1942 at 11 different manufacturing facilities across the United States. By June 1944, American industry had produced over 25,000 Shermans, with production continuing at approximately 2,000 per month. The Sherman's 75mm M3 gun fired several types of ammunition, but the M48 high-explosive round proved particularly effective for the marching fire role. Each M48 shell weighed 14.6 pounds and contained 1.47 pounds of TNT equivalent explosive. Muzzle velocity was 619 meters per second, providing a relatively flat trajectory out to 1,000 meters. The gun's gyrostabilizer system, officially designated the Westinghouse stabilizer, represented the critical technological innovation that made marching fire tactically viable. The system used an electrical servo mechanism to maintain gun elevation despite the tank's vertical motion across rough terrain. A gyroscope mounted in the turret detected vertical movement and sent correction signals to hydraulic actuators that adjusted the gun mount automatically. The stabilizer operated in elevation only, not traverse, meaning it compensated for the tank pitching forward and backward, but not for side-to-side rolling motion. This single-axis stabilization proved sufficient for combat purposes because properly trained gunners could compensate for traverse movement through experience and timing. Development of the stabilizer system began in 1938 through a contract between the United States, Army Ordnance Department, and Westinghouse Electric Corporation. Engineers faced enormous technical challenges, making a servo system rugged enough for combat use while sensitive enough to detect and correct for terrain-induced motion. Early prototypes proved unreliable, with electrical failures common and hydraulic systems prone to leaking under combat stress. By 1941, Westinghouse engineers had refined the design sufficiently for production installation. The M3 Lee medium tank, Sherman's immediate predecessor, received stabilizers beginning in mid-1941. Combat testing in North Africa during 1942 revealed both the system's potential and its limitations. Crews often deactivated stabilizers because early versions introduced additional mechanical complexity that reduced reliability, and inadequate training left crews unable to utilize the system effectively. The Sherman production models beginning in 1942 incorporated improved stabilizers with more reliable electrical components and better hydraulic seals. More critically, American training establishments began systematically teaching crews how to employ stabilized fire effectively. Fort Knox, Kentucky, served as the primary armor training center, where tank crew instruction evolved rapidly based on combat feedback from North Africa and later Italy. By early 1944, gunnery instruction at Fort Knox explicitly included moving fire exercises. Crews practiced engaging targets while their tanks traveled at speeds between 5 and 15 miles per hour across varied terrain. Instructors taught gunners to compensate for the tank's forward motion by aiming slightly ahead of stationary targets, with the compensation distance increasing based on range and vehicle speed. Training doctrine recognized that marching fire would never achieve the accuracy of carefully aimed stationary fire. The tactical purpose was not precision destruction of hardened targets, but suppression of enemy positions during assault phases. A Sherman advancing while firing forced enemy infantry to keep their heads down, disrupted defensive preparations, and maintained initiative during critical moments when stopping would have allowed defenders to respond effectively. The development of this tactical capability reflected broader differences in American versus German approaches to armored warfare. German tank doctrine prioritized long-range gunnery duels between armored vehicles, with tactics designed around the assumption that superior optics, gun performance, and crew training would enable German tanks to destroy enemy armor at distances where return fire posed minimal threat. This doctrine worked well when German forces held technical advantages, particularly during 1940 and 1941. American doctrine, shaped by different industrial capabilities and tactical requirements, emphasized combined arms coordination with infantry and commotion, artillery supporting tank operations, and tanks providing mobile firepower to enable infantry advances. This approach required tanks that could advance in coordination with foot soldiers, meaning movement at speeds between 5 and 10 miles per hour rather than maximum velocity sprints across open terrain. The Sherman's relatively low ground pressure, 13.7 pounds per square inch, allowed it to traverse soft ground that defeated heavier German tanks. Combined with reliable suspension, the Sherman could maintain tactical speeds across varied terrain while keeping its gun roughly on target through gyro stabilization. These seemingly mundane capabilities, unimpressive in technical specifications, proved tactically decisive in close terrain where long-range gunnery advantages meant nothing. German tanks lacked equivalent stabilization systems. The Panther and Tiger tanks, technically sophisticated in many respects, required complete stops for accurate fire. Crew training emphasized deliberate gunnery procedures with careful range estimation, proper ammunition selection, and precise aim before firing. These methods produced excellent accuracy from stationary positions, but proved ill-suited for fluid close-range combat in restrictive terrain. The hedgerow country of Normandy exposed these doctrinal differences with brutal clarity. The bocage terrain, ancient agricultural landscape of northwestern France, consisted of small, irregular fields surrounded by dense hedgerows planted atop earthen banks. Individual fields averaged only 100 yards per side, creating a claustrophobic combat environment where long-range visibility was rare and surprise encounters common. American forces landed in Normandy on June 6, 1944, with 3 armoured divisions and numerous separate tank battalions. By late June, these formations found themselves grinding through bocage country, where traditional armoured manoeuvre proved nearly impossible. Tank crews quickly learned that bocage combat demanded new tactical approaches, emphasizing short-range shock action over manoeuvre warfare. German defenders, primarily infantry with anti-tank guns, had transformed the bocage into a defensive strongpoint system. Machine gun positions covered field entrances. Anti-tank guns positioned to catch American tanks as they emerged from sunken lanes. Infantry teams armed with Panzerfaust anti-tank rockets waited in concealed positions to engage vehicles at point-blank range. These tactics proved devastatingly effective initially, with American armoured units suffering severe losses attempting to advance through terrain that negated most of their advantages. The tactical solution emerged gradually through hard experience and aggressive experimentation by field commanders. Tank infantry teams learned to advance in careful coordination, with infantry suppressing German positions while tanks provided mobile firepower. The critical innovation was maintaining momentum during these coordinated assaults, rather than stopping to fire and allowing defenders to respond. Sergeant Rothwell's experience near Saint-Lô on July 28 exemplified the evolved tactics. His platoon of 5 Shermans advanced in column along a sunken lane with infantry squad ahead and on the flanks. German defenders held the far end of the lane where it opened into a small field. Standard doctrine would have called for the lead Sherman to stop, identify targets, and engage from a stationary position while infantry attempted to flank the German strongpoint. Instead, Rothwell's tank kept moving forward. Gunner Hansen activated the gyrostabilizer and began firing high-explosive shells at the estimated position of the German machine gun. Accuracy was poor compared to aimed fire from a halt, with the first round impacting 10 meters left of the target, but the mere fact of high-explosive shells detonating nearby forced German defenders to take cover rather than engaging the advancing American infantry. Hansen adjusted his aim and fired twice more as the Sherman continued forward at 8 miles per hour. The third round hit close enough to silence the machine gun position, either through direct casualties or by forcing the crew to abandon their weapon. By the time the Sherman reached the field entrance, approximately 20 seconds after initiating fire, German resistance had collapsed. Infantry secured the position with minimal casualties. This engagement, repeated hundreds of times daily across Normandy during late July and August 1944, demonstrated marching fire's tactical value. The German defenders faced an impossible dilemma. Staying in position while high-explosive shells landed nearby risked death or severe wounds. Taking cover allowed American infantry to close and overwhelm positions. No good options existed once American tanks began advancing while firing. German after-action reports from Normandy explicitly noted American tanks firing while moving as a significant tactical challenge. A 7th Army report dated August 5, 1944, stated that American tank crews demonstrated high proficiency in delivering fire during movement, making it difficult to effectively engage them during their assault phase. German commanders recommended that their own forces focus fire on lead American tanks to force them to halt, as stationary American tanks were far easier targets. The practical challenge for German defenders was that the equipment and training to stop advancing Shermans often was not available. German infantry anti-tank weapons in Normandy consisted primarily of towed 75mm PAK-40 guns and Panzerfaust single-shot rockets. The PAK-40, effective against Sherman armour at most combat ranges, required careful aim from a concealed position. Firing at a moving tank that was simultaneously firing back demanded exceptional crew discipline and often proved impossible when high-explosive shells were bracketing the gun position. Panzerfaust weapons, effective only at ranges under 60 meters, required infantry to hold positions until American tanks closed to point-blank range. Marching fire made this extraordinarily difficult. German infantry soldiers attempting to engage with Panzerfausts, while under fire from advancing Shermans, faced suppression effects that made accurate aim nearly impossible. Many simply fled rather than attempting to engage under such conditions. German tank crews, when available to counter American armored attacks, found marching fire profoundly disorienting. Their training and equipment emphasized careful static gunnery. The sight of Sherman tanks advancing while firing disrupted German tactical calculations about when and how to engage. German doctrine called for engaging enemy tanks at maximum possible range, using superior optics and gun performance to destroy targets before they could close. American tanks advancing while firing forced German crews to engage at closer ranges where their advantages diminished. A Panther tank's 75mm Kebel K-42 gun could destroy a Sherman at 2,000 meters or more using standard armor-piercing ammunition. At ranges under 500 meters, however, the Sherman's greater mechanical reliability, superior crew visibility through multiple periscopes, and ability to fire effectively while moving created tactical advantages that partially offset German technical superiority in armor and firepower. German tank commanders in Normandy repeatedly noted in reports that American tank crews demonstrated aggressive tactics and willingness to close range quickly, attributes that German training had not emphasized. The psychological impact of facing tanks that advanced steadily while firing proved as significant as the physical effects of the fire itself. German crews trained to expect deliberate long-range duels found themselves engaged in close-range brawls where their carefully developed skills provided less advantage. The July 19, 1944 engagement near Coutances illustrated these dynamics. Combat Command A of the 3rd Armored Division encountered elements of 2nd SS Panzer Division Das Reich during the American breakout from the bocage. German forces included approximately 15 Panther tanks with supporting infantry and anti-tank guns, defending a series of villages that blocked the American axis of advance. American doctrine called for infantry tank teams to clear each village systematically. Sherman platoons advanced with infantry companies, using marching fire to suppress German positions, while dismounted soldiers worked forward to neutralize specific strong points. German defenders responded with long-range fire from Panthers positioned in hull-down defensive positions on rising ground beyond the villages. The engagement developed into a series of sharp combats as American forces cleared villages while German armor attempted to stop the advance with long-range fire. Sherman tanks advancing through the villages used marching fire extensively, engaging suspected German positions with high explosive shells while maintaining forward momentum. German anti-tank gunners found themselves under fire from moving targets before they could properly estimate range and aim. By late afternoon, American forces had cleared 4 villages and forced Das Reich elements to withdraw. American casualties included 11 Sherman tanks destroyed and approximately 40 crew casualties. German losses totaled 7 Panthers destroyed, 4 more abandoned due to mechanical failures, and estimated 400 infantry casualties. The engagement demonstrated that American tactics, emphasizing aggressive movement with suppressive fire, could overcome German defensive advantages in favorable terrain. The tactical effectiveness of marching fire depended heavily on crew proficiency. The gyrostabilizer system required proper maintenance and careful adjustment to function reliably. Gunners needed extensive practice to develop the timing and compensation skills that made moving fire effective. Tank commanders had to understand when marching fire was appropriate versus when halting for aimed shots made better tactical sense. Fort Knox training programs evolved continuously based on combat feedback. By early 1944, gunnery courses included extensive moving fire exercises with scoring standards that acknowledged reduced accuracy compared to stationary fire, but emphasized rapid engagement and suppression effects. Instructors taught gunners that the primary purpose of marching fire was forcing enemy heads down rather than achieving first-round kills. Training also emphasized crew coordination during moving fire. The driver needed to maintain steady speed and avoid sudden changes that would throw off the gunner's aim. The tank commander had to provide target indications while monitoring tactical, situation, and maintaining awareness of friendly infantry positions. The loader had to maintain rapid ammunition supply while the tank pitched and rolled across rough ground. Effective marching fire required the entire crew functioning as a coordinated team. Technical limitations of the stabilizer system created specific constraints that training addressed. The Westinghouse stabilizer worked well across terrain with gradual elevation changes, but could not compensate for abrupt impacts from hitting obstacles or crossing ditches. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Gunners learned to anticipate these moments and pause their firing sequence until the tank returned to smoother motion. The stabilizer's effectiveness diminished at speeds above 15 miles per hour because the servo system could not respond quickly enough to rapid terrain changes. Tactical doctrine therefore specified that marching fire should occur at speeds between 5 and 12 miles per hour, balancing the need for suppression with the requirement for reasonable accuracy. Ammunition selection significantly affected marching fire effectiveness. High explosive shells proved most useful because their blast effect created suppression even with near misses. Armor-piercing ammunition, designed for precision penetration of armored targets, provided minimal suppression effect when fired against infantry positions. Tank commanders learned to load primarily high explosive shells when planning assaults through defended areas where marching fire would be employed. The M48 high-explosive shell's effectiveness against typical German field fortifications made it ideal for the suppression role. A near miss within 5 meters of a machine gun position would shower the area with fragments and create overpressure effects that temporarily disabled defenders, even without direct casualties. Multiple rounds landing in quick succession forced defenders to take cover and disrupted their ability to return effective fire. German defenders recognized this and attempted countermeasures. Construction of more substantial field fortifications increased during late July and August 1944 as German units tried to create positions that could withstand near misses from 75 mm high. Explosive shells. Timber and earth bunkers replaced simple foxholes where time and resources permitted. These improved positions offered better protection, but required more time and material to construct, resources Germany could rarely spare during the fighting withdrawal through France. The tactical advantage American forces gained through marching fire capabilities extended beyond direct combat effects. The psychological impact of facing tanks that advanced steadily while firing affected German defensive planning and troop morale. Infantry soldiers subjected repeatedly to this tactic became less willing to hold positions to the last moment, reducing the effectiveness of prepared defenses. Tank crews learned to expect aggressive American tactics and showed increasing reluctance to engage in close-range combat, where their technical advantages provided less protection. American after-action reports from Normandy consistently noted improved crew confidence correlated with mastery of marching fire techniques. Crews that learned to employ the tactic effectively reported feeling less vulnerable during assault phases, because maintaining momentum and suppressive fire reduced their exposure to German anti-tank weapons. This confidence translated into more aggressive tactics and higher operational tempo, attributes that proved tactically valuable in exploitation phases after breakthrough operations. The broader implications of marching fire capability related to fundamental differences in American versus German approaches to weapons development and tactical doctrine. German tank design prioritized firepower and armor protection based on doctrine emphasizing long-range engagements and technical superiority over opponents. This philosophy produced tanks with impressive specifications, but often poor reliability and high maintenance requirements. American tank design balanced multiple competing requirements, including reliability, ease of maintenance, crew comfort, and tactical flexibility. The gyrostabilizer system, though it added mechanical complexity and cost, reflected American willingness to invest in capabilities that provided tactical advantages, even if those advantages could not be easily quantified in traditional performance metrics like armor thickness or gun penetration tables. The contrast extended to crew training philosophies. German tank training emphasized individual excellence, with highly skilled gunners expected to achieve first-round kills at extreme ranges. American training emphasized crew coordination and tactical flexibility with adequate individual skills, but primary focus on team performance across varied combat situations. Neither approach was inherently superior, but American methods proved better suited to the actual combat conditions encountered in northwest Europe during 1944. The hedgerow fighting in Normandy represented terrain and tactical situations that favored American strengths while negating many German advantages. Close-range combat in restrictive terrain demanded reliable mechanical performance, good crew visibility, and tactical flexibility more than extreme firepower or heavy armor. Sherman tanks, though inferior to Panthers by most technical measures, proved better suited to bocage warfare because their design prioritized the capabilities that mattered most in that specific environment. German tactical doctrine struggled to adapt to these conditions. Training and equipment optimized for mobile warfare across open terrain or deliberate defensive operations from prepared positions did not translate well to fluid combat in hedgerow country, where engagements occurred at ranges under 200 meters, and surprise encounters were common. German commanders repeatedly noted in reports that American tactics emphasized speed and aggression over careful preparation, making it difficult to establish stable defensive lines. The development of specialized tactics like marching fire demonstrated American capacity for tactical innovation based on combat experience. Field commanders facing specific problems developed solutions using available equipment capabilities, then shared those solutions through formal and informal channels. The Army ground forces rapidly incorporated successful tactical innovations into training doctrine and disseminated updated guidance to units preparing for deployment. This cycle of innovation, testing, and institutional adoption operated far more quickly in the American system than in the more rigid German military hierarchy. By September 1944, as Allied forces pursued retreating German armies across France, marching fire had become standard doctrine in American armored units. Training materials explicitly included the tactic in prescribed battle drills for various scenarios. Unit after action reports routinely mentioned employment of marching fire during assault operations. The capability, initially developed through experimentation and combat experience, had evolved into an institutionalized component of American armored warfare doctrine. The tactical evolution continued through autumn and winter 1944 as American forces encountered different terrain and defensive situations. In more open country east of Paris, the utility of marching fire decreased somewhat because longer engagement ranges made accurate aimed fire more valuable than mobile suppression. German defenders, having learned from Normandy experience, increasingly attempted to engage American tanks at maximum possible range before they could close for assault. However, even in more open terrain, the Sherman's ability to fire while moving provided tactical advantages. Tank platoons. Conducting movement to contact could engage targets immediately upon detection rather than requiring time-consuming halts. This responsive capability often allowed American tanks to suppress German anti-tank positions before they could fire, reducing American casualties during meeting engagements. The winter fighting in the Ardennes during December 1944 and January 1945 saw limited use of marching fire due to weather conditions and terrain that favored defensive operations over aggressive assaults. Snow and ice made maintaining stable movement difficult, reducing the effectiveness of mobile firing. German defensive tactics in the Ardennes emphasized prepared positions and long-range anti-tank fires that negated many advantages of marching fire. The spring offensives of 1945, however, saw extensive employment of the tactic as American forces crossed the Rhine and advanced into Germany. Urban combat in German cities resembled hedgerow fighting, in many tactical respects, with close ranges and restrictive terrain favoring mobile suppressive fire. Sherman crews used marching fire extensively during street fighting, advancing down urban streets while engaging suspected German positions in buildings and at intersections. German defenders in these final battles often lacked the weapons and training to effectively counter aggressive American tank tactics. Ammunition shortages, limited anti-tank gun deployment, inexperienced Volkssturm militia troops pressed into service, lacked the discipline to hold positions while under fire from advancing tanks. The tactical advantages marching fire provided in Normandy became even more pronounced against depleted and demoralized German forces during the final campaigns. The cumulative combat experience of American armored forces by spring 1945 demonstrated how tactical innovation, technical capability, and institutional learning combined to create substantial operational advantages. Sherman tank crews of April 1945 bore little resemblance to the green crews that landed in Normandy 11 months earlier. Months of continuous combat had produced veterans who understood their equipment's capabilities thoroughly and employed tactics refined through hard experience. Marching fire represented one component of this evolved combat effectiveness, but an important one. The capability allowed American armor to maintain offensive tempo during assaults, reducing casualties and achieving tactical objectives more quickly than doctrine emphasizing stationary fire would have permitted. Over hundreds of engagements, these tactical advantages accumulated into operational effects that contributed significantly to the speed and success of Allied advances across Western Europe. The German military's failure to develop equivalent capabilities reflected deeper problems within their industrial and tactical systems. German tank designers possessed sufficient technical knowledge to create gyro stabilizer systems, but never prioritized such development because German doctrine did not emphasize mobile firing. This represented a failure of institutional imagination, an inability to conceive of tactical approaches that might provide advantages even if those approaches contradicted established practice. The contrast with American development processes proved telling. American ordnance officers and training commanders maintained continuous dialogue with combat units, systematically collecting feedback about what worked and what did not. This information flow enabled rapid identification of capabilities that provided tactical value, even when those capabilities had not been initially anticipated or requested. The gyrostabilizer represented this pattern perfectly, a technical capability that training and operational commanders learned to exploit in ways designers had not necessarily envisioned. Post-war analysis by both American and German military organizations recognized marching fire as a significant tactical innovation. American armored doctrine in the late 1940s and 1950s continued emphasizing mobile firing capabilities, with tank stabilizer systems becoming standard equipment on all subsequent American tank designs. The M46 Patton tank, introduced in 1947, featured improved stabilization in both elevation and traverse, addressing the Sherman's single-axis limitation. German officers who survived the war and later helped establish the Bundeswehr, West Germany's military during the Cold War, studied American tactics extensively. The Leopard 1 main battle tank, developed during the 1960s, incorporated sophisticated stabilization systems enabling accurate fire while moving at speeds up to 30 miles per hour. German tank doctrine evolved to emphasize mobile warfare combining movement with fire, explicitly recognizing that Cold War combat scenarios would favor tactics the Americans had pioneered. The broader lesson that marching fire demonstrated related to the relationship between technical capabilities and tactical innovation. Technology alone never determines tactical outcomes. How military organizations employ technology, how they train personnel to exploit available capabilities, and how they adapt doctrine based on combat experience matter as much as raw technical specifications. The Sherman tank's 75mm gun was objectively less powerful than German tank guns. Its armor was thinner. Its speed was comparable but not superior. Yet American forces using Shermans achieved decisive victories against technically superior German forces because they developed and employed tactics that leveraged their vehicles' actual strengths rather than lamenting their capriced weaknesses. Marching fire capability emerged from gyro stabilizer technology that German engineers could have developed but did not. The tactic evolved from American willingness to experiment with unconventional approaches rather than rigidly adhering to established doctrine. The effectiveness of the tactic derived from systematic training that taught crews to exploit their equipment's capabilities fully. At each stage, institutional culture and organizational processes mattered more than pure technical factors. The human dimension of marching fire's development deserves emphasis. Individual tank commanders, gunners, and crew members developed techniques through trial and error in combat. Their experiences, when shared through formal and informal channels, became institutional knowledge that improved overall force effectiveness. Sergeant Rothwell and Gunner Hansen, conducting their assault near Saint-Lô on July 28, 1944, represented thousands of tank crews who collectively pioneered American marching fire doctrine through practical experience under fire. The German soldiers on the receiving end of these tactics experienced a different reality. They faced enemy tanks that violated their understanding of how armored warfare should function. German training and doctrine taught that accurate tank gunnery required stationary firing positions. The sight of American tanks advancing while firing challenged fundamental assumptions about armored combat, creating psychological effects that extended beyond the physical danger of incoming high-explosive shells. This psychological impact accumulated over time and repeated engagements. German infantry soldiers learned they could not rely on American tanks halting to fire, eliminating a predictable pause that might allow effective employment of short-range anti-tank weapons. German tank crews found themselves engaging aggressive opponents who closed range quickly, rather than conducting cautious long-range duels. These tactical behaviors, enabled by marching fire capability among other factors, forced German forces onto the defensive psychologically as well as positionally. The transformation of American armored capabilities between June 1944 and May 1945 reflected the cumulative impact of multiple tactical innovations, extensive combat experience, improved equipment, and evolving doctrine. Marching fire represented one thread in this larger tapestry of military effectiveness. Its significance lay not in any single dramatic victory, but in consistent tactical advantages across thousands of small unit engagements. Every time a Sherman advanced while firing and suppressed a German defensive position, American infantry gained seconds or minutes that reduced their casualties and hastened their advance. These small tactical victories accumulated into operational success, breakthroughs that became exploitation, exploitation that became pursuit. The grand strategic outcome of World War II in Europe resulted from millions of such small tactical events, where Allied forces proved slightly more effective than their opponents in specific engagements. The technical sophistication of German tanks and the skill of German crews mattered less than reliable mechanical performance, tactical flexibility, and doctrine that emphasized combined arms coordination. The Sherman tank, unimpressive in many technical specifications, proved exceptionally well suited to the actual demands of combat in Northwest Europe during 1944 and 1945. Marching fire capability exemplified this broader pattern, where American pragmatism and tactical adaptability overcame German technical sophistication. The evolution of American armored doctrine after World War II reflected lessons learned through practices like marching fire, but the path from wartime improvisation to institutional doctrine proved neither simple nor automatic. Military bureaucracies naturally resist change, and the immediate post-war period saw significant debate within the United States Army about which tactical innovations represented genuinely valuable developments versus techniques that worked only under specific circumstances that might not recur in future conflicts. The tank destroyer force, which had operated as a separate branch during the war, was dissolved in 1946. Its elimination stemmed partly from recognition that the combined arms approach American armored units developed in combat proved more effective than the specialized tank destroyer doctrine that emphasized defensive anti-armor operations. The marching fire capability Sherman tanks demonstrated had contributed to this assessment. Tanks that could advance while providing suppressive fire served multiple roles simultaneously, reducing the need for specialized vehicles dedicated to single missions. The Korean War, beginning in June 1950, provided the first major test of whether World War II armored tactics remained relevant against a different opponent in different terrain. The M4A3E8 Sherman, the final production variant mounting a 76mm gun with improved horizontal volute spring suspension, equipped the initial American armored units committed to Korea. These tanks retained the gyro stabilizer systems and crew training in mobile firing techniques developed during World War II. Combat in Korea initially resembled the mobile warfare of 1944 France, with North Korean forces advancing rapidly using Soviet-supplied T-34 85 tanks. American Sherman crews found their marching fire capabilities valuable during the chaotic retreat of summer 1950, when maintaining mobility while pursuing enemy forces often made the difference between successful withdrawal and catastrophic loss. Tank commanders reported that firing while retreating, though not explicitly trained during World War II, applied the same principles and equipment capabilities developed for advancing fire. The Incheon landings in September 1950 and subsequent United Nations counteroffensive created situations where advancing American armor encountered fortified defensive positions, scenarios similar to Normandy hedgerow fighting. Sherman crews employed marching fire tactics against North Korean and later Chinese defensive positions, with results comparable to World War II experience. Suppressive fire from advancing tanks proved effective at neutralizing enemy infantry positions and enabling coordinated infantry tank assaults. However, Korean War experience also revealed limitations of World War II-era equipment and doctrine. The mountainous terrain of Korea often restricted tank operations to valley floors and road networks where mobility advantages diminished. The Chinese People's Volunteer Army employed infiltration tactics and close-range ambush techniques that negated many advantages of mobile armored warfare. American forces increasingly relied on static defensive positions during the latter phases of the war, situations where marching fire provided less tactical value than precise long-range gunnery from hull-down positions. The M46 Patton tank, which began replacing Shermans in Korea during 1951, featured improved stabilization systems enabling more accurate fire at higher speeds. The technical evolution continued principles, established with the Sherman's gyrostabilizer, but reflected both improved technology and lessons learned about stabilizer system limitations. The M46 stabilizer operated in both elevation and traverse, addressing the Sherman's single-axis limitation that required gunners to compensate manually for horizontal motion. Soviet tank development during the same period followed remarkably different paths despite Soviet forces having captured numerous German tanks and having access to extensive German technical documentation after the war. Soviet designers emphasized firepower and armor protection over stabilization systems and fire-on-the-move capabilities. The T-54 medium tank, which entered production in 1947 and became the Soviet Army's standard tank, lacked stabilization systems despite Soviet engineers having access to captured German documentation describing Allied stabilizer technology. This design choice reflected Soviet tactical doctrine, emphasizing mass assault tactics and accepting that individual tank accuracy would be relatively poor. Soviet planners calculated that overwhelming numerical superiority and concentrated fire from large tank formations would compensate for reduced individual vehicle accuracy. This philosophy represented a fundamentally different approach than American doctrine, which emphasized individual crew proficiency and tactical flexibility enabled by technical capabilities like stabilization systems. The divergence in design philosophies had significant implications for Cold War military balance. NATO forces, organized around American doctrine and often equipped with American tanks or designs influenced by American principles, emphasized quality over quantity, with highly trained crews operating sophisticated equipment. Warsaw Pact forces, following Soviet doctrine, emphasized quantity and accepting higher individual vehicle vulnerability in exchange for numerical superiority and simpler equipment that required less training to operate adequately. The Arab-Israeli wars of 1967 and 1973 provided combat testing of these competing approaches under conditions somewhat comparable to World War II European theatre. Israeli armoured forces, equipped initially with World War II-era Sherman tanks, upgraded with more powerful guns, and later with American M48 and M60 Pattons, faced Arab armies equipped with Soviet T-54 and T-55 tanks, plus more modern T-62 models. Israeli tactical doctrine emphasized aggressive maneuver and exploitation of crew training advantages, approaches conceptually similar to American World War II tactics. Israeli Sherman tanks, some still in frontline service during the 1967 Six-Day War, demonstrated that World War II-era vehicles with capable crews and sound doctrine could defeat more modern opponents under favorable circumstances. Israeli tank crews employed mobile firing techniques during rapid advances across the Sinai Peninsula, using principles fundamentally unchanged from 1944 Normandy, despite 23 years of technological development. The essential lesson remained valid. Tanks that could deliver effective fire while maintaining momentum gained tactical advantages over opponents requiring complete halts for accurate shooting. The American M60 Patton tank, which became the United States Army's standard main battle tank during the 1960s, represented evolutionary development from Sherman through M46 and M48 Pattons. Each generation incorporated improved stabilization systems, more powerful guns, and better armor protection. But the fundamental design philosophy remained consistent. American tanks would emphasize reliability, crew effectiveness, and technical capabilities that enabled tactical flexibility rather than pursuing maximum theoretical performance in individual categories. The development of the M1 Abrams tank during the 1970s and its introduction in 1980 represented the culmination of doctrine and design principles, with roots extending directly to World War II. Sherman development. The Abrams featured sophisticated stabilization systems, enabling accurate fire while moving at speeds exceeding 40 miles per hour across rough terrain. The capability that Sherman crews pioneered with their Westinghouse stabilizers had evolved through decades of technical refinement into systems that made modern tanks essentially mobile artillery platforms capable of delivering precision fire without stopping. The psychological impact on enemy forces facing tanks with advanced fire on the move capabilities paralleled what German defenders experienced in Normandy. Iraqi forces during the 1991 Gulf War and later conflicts discovered that American tanks could engage accurately while advancing at high speed, a capability Iraqi crews using Soviet doctrine tanks lacked. The tactical advantages this provided proved as decisive in 1991 as they had been in 1944, demonstrating that fundamental principles of armored warfare remained consistent despite technological change. The legacy of marching fire extends beyond technical capabilities to encompass broader lessons about military innovation and institutional adaptation. The United States Army's willingness to adopt unconventional tactics based on combat experience, invest in technical capabilities that provided tactical advantages even without obvious peacetime applications, and train crews systematically to exploit available equipment represented institutional strengths that proved as important as industrial capacity or technical sophistication. These organizational attributes, visible in the development and employment of marching fire during World War II, remained characteristic of American military culture through subsequent decades and conflicts. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.